So this is the 62nd video on Newton's laws of motion. This is in continuation of the 61st video. In this video also I'll take up a numerical problem on Newton's laws of motion using the concept of pseudo forces and combined equation of motion. Okay. So I'll write down the question here. Question is this. A smooth wedge of mass 4m and angle and alpha equal to 30 degree is free to move on a smooth horizontal plane. Horizontal plane in a direction perpendicular to its edge. In a direction perpendicular to its edge. A block of mass m is projected directly up the face of wedge, up the inclined face of the wedge. With initial speed u equal to 20 meter per second. Take g equal to 10 meter per second square. Find the time t after which the block returns. The block returns to initial location of wedge. After which the block returns to its initial location of the wedge. This is the question. Okay, fine. Everything has been stated in the problem. Okay. I'll draw the diagram of the situation. See, the diagram is this. This is a smooth horizontal surface. This is a wedge of mass 4m. This angle alpha is given to be 30 degree. Here there is a block of mass m. This block is initially projected up the inclined plane with initial speed u equal to 20 meter per second. We have to find after what time the block will return to its initial location on the wedge. Initially the block was at the lowest location of the wedge. Now we have to find out after what time the block will again return to its initial location of the lowest point of the wedge. Okay. G will take to be 10 meter per second square. Okay. And there is no friction anywhere. Fine. There is no friction anywhere. Alright. And rigid wedge is block assumed to be rigid bodies. Now see, first of all, this is a smooth horizontal surface. Wedge can slide over this smooth horizontal surface. as the block will move up the wedge incline, it will exert a normal force on the wedge in this direction. The rightward component of the normal force on the wedge will cause the wedge to accelerate rightward. Okay. So in course of motion, this wedge will accelerate towards rightward direction with respect to ground. And with respect to wedge, the block will rise. Now, what will happen, see, there are two phases of motion of block with respect to wedge. Firstly, the block will rise up the wedge, then momentarily comes to rest, and then again begin to slide down the wedge. Okay. So there are two phases of motion of block on the wedge incline. Phase 1. Phase 1 is this. This is the wedge. The block is rising up the wedge incline. The block is rising up the wedge incline. Now, due to its weight, component of weight mg sin alpha, as it rises up the wedge, its speed will decrease with respect to the wedge. That is, the block will decelerate with respect to the wedge. So as it rises, its speed with respect to wedge goes on decreasing. It momentarily comes to rest at the highest location of the wedge incline. And again, due to component of its weight mg sin alpha, it begins to slide down the wedge. So in the phase 1, it is the upward journey of the block with respect to the wedge. Okay. So in phase 1, suppose, now what I have to see, what I'll do, I'll simply prove that in both the upward and the downward journey of block on the wedge incline, acceleration of block with respect to wedge has a constant magnitude and it is directed down the incline throughout the entire course of motion of the block over the wedge incline. Okay. Is it clear what I am saying? I'll just simply prove that in both the phases, in upward journey and downward journey of block on the wedge incline, acceleration of block with respect to wedge has a constant magnitude and it is always directed down the wedge incline. Okay. And then the problem will be solved very easily by using that formula d equal to ut plus half at square with respect to wedge. Okay. So in phase 1, we consider the upward journey of the block over the wedge. Now what I do, I draw the free body of this wedge. Okay. Free body of the wedge I draw. I draw the free body of the wedge here in this diagram itself. Here I draw it, okay. Same wedge I have drawn here, not drawn to scale, okay. I draw the free body diagram of the wedge with respect to ground, okay. So here the weight of the wedge is 4 mg. The ground exerts some normal force, say n dash on the wedge. And the rising block exerts a normal force n1 say on the wedge in this direction. This is the free body of the wedge with respect to ground during the upward course of motion of the block over the wedge incline. Assume that the wedge has an acceleration of a1 in down the rightward direction. Now this angle by geometry will also be 30 degree. Okay. I apply Newton's second law to the wedge with respect to ground in rightward direction. N1 sin 30 degree equal to 4ma1. Sin 30 degree is 1 by 2. N1 becomes 8ma1. Okay. Let us call this equation as equation 1. Now what I do, I draw the free body of block with respect to wedge during the interval in which it rises up the wedge incline. So mg, weight of the block due to ground. By Newton's third law, the wedge exerts a normal force n1 on the block in this direction. Now this wedge is a translating frame, non-inertial reference frame. As seen from wedge, a pseudo force will act on the block towards leftward direction, opposite to a1. Its magnitude will be ma1. Now see, during the course of motion, when the block rises up the wedge incline, it slows down with respect to wedge. That is, in upward journey it is moving up the wedge incline, but it is slowing down with respect to the wedge incline. This means in upward journey, acceleration of block with respect to wedge is directed downward and has a magnitude say b1. Okay. Now apply Newton's second law to block with respect to wedge down the wedge incline. Okay, fine. So what do I write? Mg sin 30 degree plus ma1 cos 30 degree is equal to m times b1. Okay, now m goes away. What do we get? G by 2 a1 root 3 by 2 b1. This is the second equation. Alright, fine. Now what I do, I apply Newton's second law to block with respect to wedge in this direction. Okay, so free body has already been drawn. I'll draw this diagram. Okay, I apply Newton's second law to block with respect to wedge in this direction along n1. So what do I write? n1 plus ma sin 30 degree, ma1 sin 30 degree. This is 30 degree by geometry, 30 alternate angles. ma1 sin 30 degree minus mg cos 30 degree is equals to mass times acceleration of block with respect to wedge in this direction, which is simply b1 cos 90 degree, that is 0. Cos 90 degree is 0, so this term goes away, this is 0. So what do we get? n1 becomes mg root 3 by 2 minus ma1 by 2. This is the third equation. Is it alright? Fine. So first equation is this, n1 equal to 8 ma1. Second is g by 2 plus a1 root 3 by 2 equal to b1. And third, n1 is equal to mg root 3 by 2 minus ma1 by 2. Okay, fine. I rub this one. Now we consider the downward journey of block over the wedge incline. On this thing, in this problem, one thing is being assumed, that the length of the inclined faces of the wedge is sufficiently long, so that the block doesn't cross over the wedge and goes somewhere outside in forward direction relative to wedge. L is sufficient, length of the wedge incline is assumed to be sufficiently long, so that the block doesn't cross over the wedge and move ahead of wedge. So that we are assuming is not happening. Length of wedge is sufficiently large so that it comes to rest with respect to wedge before reaching the topmost point of the wedge. Okay. Now we take the phase 2 of second phase of journey of block over the wedge incline. Phase 2. Downward journey of block on the wedge incline. Okay. Again, what I do, so in the second, this block is moving down with respect to wedge. And wedge is as usual still moving rightward, because the block still exerts a normal force on wedge in this direction only. So wedge will continue to accelerate in that direction. Okay, fine. Suppose wedge has a rightward acceleration of a2 with respect to ground. During the course of motion, the block moves down the wedge incline. Suppose the block has an acceleration of v2 with respect to wedge. Okay, fine. Suppose the ground exerts a normal force n double dash on the wedge during the course of motion of downward motion of the block. Okay. See, n dash and double dash, they will all be same. A1, A2, they will all be same. But still, for the sake of explanation, I am assuming different symbols. Okay. I am explaining it. Alright. Now what I do, again I draw the free body of the wedge with respect to ground. Okay. So here it is 4 mg. Here it is n double dash. Suppose in downward journey, the block exerts a normal force n2 on the wedge. Suppose in second phase 2, acceleration of wedge with respect to ground is a2 rightward. I again apply Newton's second law to wedge in rightward direction. I write it here. Here I write this one. What do I write? This is again 30 degree by geometry. So n2 sine 30 degree equal to 4m into a2. n2 becomes 8m a2. This is the fourth equation. Alright, fine. Now what I do, I apply Newton's second law to block with respect to wedge down the incline. For this, what I do, I draw the free body of block with respect to wedge during its downward journey. mg n2 by Newton's third law and pseudo force ma2 in leftward direction. Okay, this is ma2. It is very small, I've written. It is ma2. Okay. I again apply Newton's second law to block down the wedge incline. What do I write? ma2 cos 30 degree plus mg sin 30 degree is equal to mv2. Now m goes away. Putting the values of these angles, sine of and cos of these angles. This is the fifth equation. Okay, fine. Now I remove this one. Okay, fine. Finally, I apply Newton's second law to block with respect to wedge along n2. So what do I write? n2 minus plus ma2 sin 30 degree minus mg cos 30 degree is equal to mb2. Okay. So n2 becomes how much? mb2 plus mg root 3 by 2 minus ma2 by 2. This is the sixth equation. Alright, fine. Now see, one thing I'd like to say. In upward journey, n1 equal to 8 ma1. In downward journey, n2 equal to 8 ma2. They have the same form. Upward journey, g by 2 plus a1 root 3 by 2 equal to b1. In downward journey, g by 2 plus a2 root 3 by 2 equal to b2. Again, they have the same form. And n1 equal to mg root 3 by 2 minus ma1 by 2. n2 is equal to m2 is equal to this will be 0. Sorry, this will be 0. b2 cos 90 degree. That was just a careless mistake. I hope it is all right. That I've clarified it. Okay. So it will be b2 cos 90 degree. Component of acceleration of b2 of block with respect to wedge in this direction, that is b2 cos 90 degree, that is 0. So this is n2. Okay. Fine. So see the correspondence. n1 equal to 8 ma1, n2 equal to 8 ma2. They have identical forms. See upward journey, g by 2 plus a1 root 3 by 2 equal to b1. g by 2 plus a2 root 3 by 2 equal to b2. n1 equal to mg root 3 by 2 minus ma1 by 2. m2 is equal to mg root 3 by 2 minus ma2 by 2. So they again have the same form. So what does this imply? This implies that in both upward and downward journey, n1 and 2 are equal, which implies a1 a2 are also equal to a say. Alright, a1 a2 both are equal, a say, and this will imply that b1 b2 they will also be equal. b1 is equal to a1 root 3 by 2 plus g by 2. b2 is equal to a2 root 3 by 2 plus g by 2. Since a1 a2 are equal, a equal, so b1 b2 are also equal to b say. Fine. b1 equal to b2 equal to what? B say. So this I have proved now that during the entire course of motion of block on the wedge incline, acceleration of block with respect to wedge has a constant magnitude in downward direction, and its magnitude b1 b2 are both equal, that is and denoted by b say. So this I have already proved. Okay, fine. Now what we have to do, we have to find after what time the block will return to its initial lowest location of the wedge. I'll rub this one. Okay, so now you see, I'll use this equation itself. So what is b1 b2 are both b, this is also b. So b is equal to g by 2 and a1 also is replaced by a, they are both equal, a root 3 by 2. Okay. Now to know B, now see, we have to find the time. Okay. Now first of all, what do you do? I find A first. A1 and A2 are both equal. N1 equal to 8m A1 and N1 equal to this. They are both same. Equation 1 and 3. So 8m A1 is equal to mg root 3 by 2 minus ma by 2. M will go away. This is also 8 such A1 and A2 are both A. A से denote किया है. So A being at this side 17a by 2 g root 3 by 2. A becomes g root 3 by 17. Okay, fine. I hope it is perfectly clear. 8 times A1 equal to mg root 3 by 2 minus ma by 2. 17a by 2 equal to g root 3 by 2. So A is equal to g root 3 by 17. This is a constant value, okay? Now I'll substitute A in this equation. Now I substitute this value of A in this equation. So B becomes what? A becomes g root 3 by 17. So this becomes g by 2 plus 3g by 34. This becomes 34. This becomes 20g by 34. 34 I have taken common. 17 plus 3 20g. This becomes 10g by 17, which is a constant value. So now we have proved that during the entire course of motion of block on the wedge incline, acceleration of block with respect to wedge has a constant magnitude of 10g by 17 in direction down the incline. Now with respect to wedge, its acceleration is constant, and with respect to the wedge, the block is moving in a straight line with initial velocity v with respect to wedge. So d is the displacement of block with respect to wedge in time 0 to small t. That is same as ut minus half bt square. Why minus? U is directed up the incline and b is taken down the incline. I have taken upward direction to be positive. Now what is this d? D is the displacement of block with respect to wedge incline in time t seconds after its projection from lowest point of the wedge. Now when the block again returns to its initial lowest location of wedge, displacement d becomes 0. And then corresponding t we have to find. So when the block returns to its initial location of the wedge, d is 0. So ut minus half bt square is 0. So ut is equal to bt square by 2. So one t goes away, t becomes 2u by b. T becomes what? 2u by b. This is the value of t. 2u is how much? U we have taken to be 20. And b is how much? 10g by 17. In this much seconds, the block will return to the lowest location of the wedge. The block will return to the lowest location of the wedge after this much seconds. 2 into 20 by 10g by 17. Alright. I'll wrap this one, fine. So, t becomes 2g, that is 40 into 17, g is 10, 10g becomes 100. This 0 goes away, 2 cancels out, 34 by 5 second. This is therefore the required answer. 2 and 5, 2 cancels out, okay. That is just 6.8 second is the required answer, okay. So block will return to the lowest location of the wedge after time 6.8 seconds. Is it alright? Fine. So this is therefore the required answer. So this example I have taken. You go through it properly. In case you have some doubt, put it in the comment box. I'll explain it, clarify it. Okay. So I hope this example is perfectly clear. So this problem I did not use the combined equation of motion concept. I simply used the translating frame concept, that's all. Pseudo force concept I used. I did not use any combined equation concept, okay. So So this I hope it is clear to you. Fine. So this I close it here.